Welcome to the Delvex course Solar Energy. My name is Arno Smets and I will be your lecturer for the coming 8 weeks. This course is a general introduction into the variety of technologies which harvest the energy in solar light and convert it into electricity, heat or fuels. In this first block I would like to give you a short overview of the course. The course can be divided in 3 major parts. The first part, week 1 up to 3, covers the fundamental physical principles on which the solar energy technologies are based. The second part, week 4, 5 and 6, discusses all solar energy technologies. The third and the last part, week 7 and 8, discusses the solar energy system. At the end, you are expected to be able to design your own solar system. The lectures are given in short video clips of around 10 minutes like this one. Between all video clips you will find many exercises. In addition, we have included more general questions, which can act as a discussion material for the students on the course block. We encourage you to participate in these lively discussions. My experience is that we can learn a lot from each other. Last edition we had some great interaction between students on the forums. Later in the course you will have the opportunity to share the solar energy technology from your home, neighborhood or city through pictures or self-made YouTube movies. At the end of each of the 3 parts we will have a short exam which covers the material discussed in that part of the course. This means that you can do an exam at the end of week 3, 6 and 8. Supplementary to the lectures, exercises, assignments and exams, we offer you a new educational book from the Photovoltaic Material and Devices group at the Delft University of Technology, entitled Solar Energy: Fundamentals, Technologies and Systems. Now I will give a more detailed overview of the course content for each week. In week 1, I will give you a general introduction into solar energy. I will discuss the variety of technologies for energy conversion we are using today for our energy needs. I will try to put the role of solar energy in perspective in reference to other energy sources. I will teach you the difference between photovoltaic and solar heat. You will be introduced to the concept of photovoltaics and its related technologies. The current status and prospects of solar energy will be discussed as well. In addition, I will give a quick overview of the history of solar technology. Finally, I will finish this week by discussing some important physical properties of the energy source itself, sunlight. Week 2 is the most fundamental week of the course. I will introduce you to semiconductor physics and how we use semiconductor materials in devices to directly convert solar light into electricity. Don't be afraid if physics is not your thing. I'm using many animations like this one to explain the physical principles of semiconductor materials and photovoltaic devices. In week 3 we will discuss how we determine the performance of solar cells using the external parameters like open circuit voltage, short circuit current density, fill factor, maximum power point and conversion efficiency. In addition, I will discuss the general design rules for solar cells. The basics you learn in the first 3 weeks form an excellent toolbox to understand the various solar technologies and solar systems we introduce in the last 5 weeks. Note that week 3 has the highest workload, so please divide your time wisely. After week 3, you will have your first small exam based on part 1. In week 4 we will discuss the most dominant solar cell technology, which is based on crystalline silicon wafers. We will discuss the processing methods, the various different device concepts and the challenges of the crystalline silicon PV technology for the future. In week 5, we will discuss the other PV technologies based on thin films. Thin film PV technology uses less materials and is produced by cheaper processing methods to further reduce the cost price of solar energy. In addition, we discuss the concentrator multi-junction solar cells, which have up to date the highest conversion efficiencies among all PV technologies. In week 6, the future generation concepts are discussed, which are supposed to beat the Shockley-Queisser efficiency limit of a single junction solar cell. Secondly, I will introduce you to solar heat and concentrated solar power technology. Finally, we will talk about the solar fuel technology. Photoelectrochemical approaches will be discussed. After week 6, we will have the second exam moment, covering weeks 4, 5 and 6. In week 7, we start to discuss the PV system. We will introduce you to other components of the PV system, such as the battery, inverters, maximum power point trackers and charge controllers. In week 8, we will discuss the most popular system topologies, like off-grid systems and grid-connected system. We will provide you the tools to be able to design any PV system on paper for any application. After week 8, you will have your last exam. One of the most beautiful aspects of this course is that solar energy is interesting for people from different study backgrounds to come and learn about it. Although this course is aimed at bachelor level students, anybody with a good grasp of high school physics and mathematics, and especially an open mind, can not only understand but also enjoy this course experience. Only a very few exercises or assignment questions require basic calculus. But don't worry, if you are not skilled in calculus, you are still able to successfully complete the course. In addition, I realize that people with various backgrounds participate in this course. Therefore, in the first week, we start with exercises to make people familiar with the typical units used during the course. So, the course has been designed to take you through the various aspects of solar energy discussed before over the 8 weeks in a gradual way. The exercises will increase your comfort level with using basic math to understand solar energy better. So, after this introduction, let's get started. Solar energy technology is based on the conversion of energy of light into electricity, heat and solar fuels. It means we are talking about energy conversion. We will discuss that in great detail in the next block. See you in the next block.